Hi, my name is Bahadur Ahmedov. In this video lecture, we are going to discuss how we can find areas on the curves approximately. First of all, let me remind you how we used to find areas of a rectangle. So if you're given a rectangle with the height h and with the width omega, then the area of this rectangle A is going to be equal simply the multiplication of the h to the width. So for example, if the width is equal to the 2 meters and if the height is equal to the 3 meters, then the area is going to be equal to the 6 meters in the square. Well, I would like to now figure out what is the area under some curves. So let's say I'm going to start from the simple examples. If you're given a function which is going to be simply, let's say f of x is equal to the 2, so which is simply a horizontal line. F of x is equal to the 2 is simply a horizontal line. And I would like to figure out its area between 2, 3, 4, and 5, let's say. So I would like to figure out what is going to be this area under this curve between 1 and 4. Well, in order to do this, I need to know the height of this. So you see that this area is a rectangular area, and we know what is the width already. The width is going to be equal here. So the width is going to be equal to the difference between 5 and 1, which is equal to the 4. What we need to do is we need to find the height. So in order to find the height, we need to find the y coordinates of these 2 points, for example. So let me think about what is the coordinate of this point. It's going to be 1 and f of 1. And the coordinates of this point is going to be equal to the 5 and f of 5. So it's always necessary to substitute x to here in order to get the y coordinate of a point on the curve. Well, if you substitute 1 to here, it is going to be equal to the 2. And if you substitute the 5, it's also going to be equal to the 2. Well, the height of this rectangle is going to be equal to the 2. So the height is equal to the 2, the width is equal to the 4. So that's why the area is going to be equal to the 8. So we just multiply the width to the height. So this is how we can find the areas under the curves if this area is a rectangle. But what if the area under the curve is not a rectangular area? So let's assume that I've got a parabola. So I would like to draw this line one more time. So let's say we've got a parabola. Y is equal to the x in the square, the usual one. So y is equal to the x in the square. And I would like to figure out its area. So the area under this curve from 0 to the 2, let's say. So let's say it's going to be 2. And it's going to be here, 1. Okay. So we would like to find this area. Okay. So the thing is, we know how to find the areas of the rectangular figures only. So since this is not a rectangular figure, what we can do is we can approximate this. So let's assume, so let's just split this area into the two rectangles. So let me split this into this rectangle, for example, and this rectangle. So let me show you what kind of rectangle I'm going to create. So this is going to be the first rectangle here, and this is going to be the second rectangle. Wow. So obviously it's going to be simply a very weak approximation, a very bad approximation, but still we can find this. So in order to now figure out what are the areas of the rectangles, we need to use both of the equation of the curve and both the points on the x-axis. So here, the coordinates of this point is going to be equal to the 1 and f of 1. And the coordinates of this point here is going to be equal to the 2 and f of 2. The reason why we need the f of 1 and f of 2 is that the f of 1 is going to give me the height of the first rectangle, and f of 2 is going to give me the height of the second rectangle. And the width in both of the cases is going to be equal to the 1. So the width is 1 here, and the width is equal to the 1. Well, let's first of all find what is f of 1. So the f of 1 is going to be equal to the 1 in the square, which is equal to the 1. So that is why the area of the first rectangle is going to be equal simply 1, because it is the height is equal to the 1 and the width is equal to the 1. And the area of the second rectangle can be found by just multiplying f of 2, which is 2 in the square, which is 4, to the width of this rectangle, which is equal to the 1. So the area of the second rectangle is equal to the 4. So the overall area is going to be equal to the 5. So overall area is equal to the 5. Well, this is very bad approximation because you can see that the area under this curve is not the same as the area of these two rectangles. So what we can do is we can probably increase the number of the rectangles from 2 to the 4 maybe. So let's increase the number of the rectangles from 2 to the 4. So let me denote this n to be the number of the rectangles to be equal to, so as number of the rectangles to be equal to the n, and in this case it's going to be equal to the 4. So as we are going to go further and further, I would like to just introduce some notation and we're going to discuss them further. So let's say this is our function and we are given this function from 0 to the 2. So now instead of splitting this into the 2, I'm going to split this into the 4 pieces. So 1.5. Okay, so you see, so if you're given the region A, let's say, from 0, B until 2, then if you're given the number of the rectangles, the width of the rectangles can be found using this formula. So the width of each of these pieces, so this piece, which is going to be equal to the 0.5, is going to be equal to the b minus a divided to the n. So this is one of the most important formulas in our concept of finding the areas. And again, if you apply this formula, so in this case, it's going to be delta x is equal to, so the delta x here is going to be equal to 2 minus 0 over 4, which is going to be equal to the 0.5. So the delta x here is also 0.5, the delta x is here is also 0.5, and here as well. So every time if you would like to find the next point here, so you start from the 0, the next point is going to be 0 plus the delta x. So plus delta x is going to give you 1, plus delta x is going to give you 1.5, plus delta x is going to give you 2. So now we're going to create the rectangles. So I'm going to create the rectangles like this. The second rectangle is going to be like this. The third rectangle is going to be like this. And this is going to be the last rectangle. Yeah, what we need to do is we need to figure out the areas of these 4 rectangles. In order to do this, we need to find the coordinates of these points. So the coordinate of the first point is going to be, so again, our curve is given with the equation y is equal to x in the square. So if you know the x, which is equal to the 0.5, then the y is going to be equal to the x in the square. So in this case, it's going to be 1 over 2 and 1 over 4. Well, the coordinate of the second point here is going to be equal to 1 and 1. The coordinate of the third point is going to be equal to the 3 over 2, which is 1.5, and 9 over 4. And the coordinate of the last point here is going to be equal to the 2 and 4 again. So now we are going to find the areas of the 4 rectangles. So the area of the first rectangle, A1, is going to be equal to the width, which is equal to the 0.5 times the height, which is equal to the 1.4. So let me write this with the ratios, 1 over 2 times the 1 over 4, which is equal to the 1 over 8. So the area of the second rectangle, A2, is going to be equal to, again, the width, which is 1 over 2, times the height, which is 1, which is equal to the 1. So let us go further. So the third area, A3, is going to be equal to 1 over 2 times to the 9 over 4, which is equal to the 9 over 8. And the area of the last rectangle is going to be equal to the A4, which is equal to the height. So the height of all of these rectangles, please note that they are f of x. So here, if x is equal to the 2, f of x is equal to the 4, then the height of the rectangle is equal to the 4, is equal to the value of the function. So it's going to be equal to the 4 times the 1 over 2 is equal to the 2 simply. So now we are going to sum all of these areas in order to get the area under the curve. It's going to be equal to the 1 over 8 plus 1 plus 9 over 8 plus 2. So just let me just give a common denominator to be equal to the 8. In this case, it's going to be 1 plus 8 plus 9 plus 16 over 8. And in this case, it's going to be equal to the 26 plus 34 divided to the 8, which is now around 4, right? Which is much smaller than the 5, but still, this is very bad approximation. So in order to improve our approximations, we just need to increase the number of the rectangles again. So let's do one more iteration together. So I'm going to do the same thing as we did before. So this is our curve. Y is equal to the x in the square, or f of x is equal to the x in the square. And then I'm going to split this area, not into the 4, but into the 8 pieces. So let's say this is going to be 2. And we are going to start from the 0. So this is A, and this is the B. So if n is equal to the 4, or 8 in this case, what is going to be the width of each of the rectangles, or each of the pieces, intervals? So, well, we are going to use the formula again. The delta x is equal to the b minus a divided to the n. So in this case, it's going to be equal to the 2 minus 0 divided to the 8, which is equal to the 1 over 4, or 0.25. The width of each of the rectangle is going to be equal to the 1 over 4. So here it's like 1, so this is 0.5, here is 1 over 4, here is like 3 over 4, here we have 1.5, so 1.25 and 1.75. Oh, well, so let me write this a little bit differently now, because I would like to now derive a general formula. So that's why I'm going to start from the A. So this point here is going to be called as a x1. Let's say, let me call this as x0, which is equal to the 0. x1 is going to be equal to the x0 plus delta x. So in this case, it's going to be equal to 1 over 4. So this point here is going to be equal to the x2, which is equal to the x1 plus delta x, or x0 plus 2 delta x. In this case, it's going to be equal to 1 over 2. So this point here is going to be x3, which is x0, or let me write somewhere else. So this point here is going to be x3, this is x4, x5, x6, x7, and x8. So we started from the x0 and we finished with the x8. So x0 is equal to simply 0. x1 is equal to the x0 plus delta x, which is equal to the 1 over 4. x2 is equal to the x1 plus delta x, or if you just substitute this to here, it's going to be x0 plus 2 delta x, which is going to be equal to the 1 over 2. So x3 analogously is going to be x0 plus 3 delta x, which is going to be equal to the 3 over 4, and so on. So x8 is going to be equal to the x0 plus 8 delta x, which is going to be equal to the 8 times the 1 over 4, which is equal to the 2, which is correct, right? So now, so this is going to be x2, x1, x2. I'm going to create all of the rectangles. So here I'm going to get the first rectangle. This is going to be the second rectangle. This is the third rectangle, the fourth rectangle, fifth rectangle, the rectangle number 6, 7, and 8. So so the width of the rectangles are easy to find, so they are given as a delta x. So the width of every rectangle is going to be equal to the delta x. So in this case, is equal to the 1 over 4. So the heights of the rectangles actually are going to be given as the coordinates of the points on the curve at that certain point. So here, so the coordinates of this point is going to be x1 and f of x1. So the coordinate of this point here is x2 and f of x2, and so on. The coordinate of the last point here is going to be equal to x8 and f of x8. Well, then it's going to be always the height times the width. So the width is delta x, the height is going to be f of x1, f of x2, and so on, f of x8, right? So the area of this rectangle here is going to be equal to delta x times tz, delta x times the f of x8, or the area of this rectangle here is going to be equal to delta x times the f of x7, and so on. So let us make the summation. So the total area is going to be the delta x times t. So what is going to be the area of the first rectangle? Delta x times the f of x1, right? So the delta x plus f of x1 plus the delta x times the f of x2 is going to be the second area, and so on, plus delta x times the f of x8 is going to be the last area. So we can take out the delta x from the brackets, and what we have here is f of x1 plus f of x2 plus and so on plus f of x8. And we can write this down as a sigma notation. It's going to be the summation of I goes from 1 to the n delta x times the f of xi. So that's going to be the area approximately. So the area approximately is going to be the summation of I goes from 1 to the n delta x times the f of xi. So in general, if you would like to find, it appears, the exact area, we need to increase this n. So you see, so if you remember the first pictures here, so the first approximation here was very bad. This was our first approximation. When x is equal simply to the 2. When n, the number of the rectangle, is equal to the 2. And that was the second approximation. Where the number of the rectangles is equal to 4. Then we made even better approximation when the number of the rectangles is equal to the 8, and so on. So you see, so as we increase the rectangles, the number of rectangles, our approximation is becoming better and better. So if you would like to figure out exact area, it appears we need to basically find the limit of the sum when n goes to the infinity. So when n goes to the infinity, delta x times to the f of xi. Well, it appears this limit, so when we find the summation of the areas of the rectangles, when the number of the rectangles goes to the infinity, is going to be the integration. So the integration of the function f of x dx from a until the b. So that's going to be the definition of the integration, and later on we are going to discuss how we actually evaluate this integration. And in this lecture, we are going to we are simply trying to understand what is the integration. So let's do a couple of numerical simulations to try to understand this concept with some illustrations. So we have this function here, so which is f of x is equal to the x in the square. So, well, if you remember, we evaluated this area here, I think. So it should be from 0 to the 1, probably. But you can see here that as we increase the number of the rectangles, so here it is choosing the midpoint. I'm going to choose the right point. So here it is exactly. So if you remember previously, if you just split this area under the x and the square into the two pieces, then the approximate area is equal to the 5. If I increase the number of the rectangles from 2 to the from 2 to the 4, then the approximate area is going to be equal to 3.75. Okay, if we increase the number of the rectangles to be equal to the 8, so in this case it's going to be equal to 3.18, while the exact area is equal to the 2.66. So as we increase the number of the rectangles, you see, so if we choose, for example, 40 rectangles, then the approximate area is going to be very similar to the exact area, because you can see here in the image as well that the areas of the rectangles are going to accumulate, are going to express the area under this curve. And that's the base